Today we're looking at graphing rational functions. So that's the technical title of it. This right here would be a rational function. That's the fancy word for it. So today we're just looking at and focusing in more on graphing those. Looks like we have lots of practice problems, 7 of them, but depending on where we're at with time, then we might speed through those. So here's our definition. A rational function is a function in the form y equals a polynomial over a polynomial. Does anyone remember the 3 types of polynomials that we talked about? What was Yeah, monomial, 1 term, binomial, 2 terms, trinomial, 3 terms. Those are the main ones we focused in on. So we have a polynomial divided by a polynomial, where the denominator does not equal 0, right? Because if we have 8 over 0, that is undefined. We're in big trouble. So the denominator cannot equal 0. The most basic rational function is y equals 1 over x. That would be considered our parent function. When we talked about just a second ago in the warm-up, y equals x squared, this was the parent function of our quadratic. So when we look at the parent function of all these rational functions, it is this right here, the parent function. Everything changes and moves based on the parent function. Questions so far? Don't feel like you have to get that whole big sentence or 2 sentences down on rational functions. It's just when I talk about, when we see the term rational functions, I just want you to know that it that's a polynomial over a polynomial. That'll be important. Here's a new term for today. We've been talking about this term, but we haven't called it this yet. Because division by 0 is undefined, which we talked about, the value of the denominator of a rational function cannot be 0, right? We can't let it be 0, no matter what. So the domain of a rational function excludes the value that makes the denominator 0. Like when we were the problem on the board. We have the domain and range. It's all real numbers except for when x equals 0. So we exclude x equals 0. This value is called the excluded value of a rational function. So whatever that denominator cannot equal. Are you looking for weird things on the slide right now? Huh? That value that the bottom cannot equal is our excluded value, which kind of makes sense, right? We're excluding it from our domain or from our domain. So here's an example. Now in this case, on the bottom, we don't just have x, we have x plus 5. So what would make the bottom 0? What value? What would make this 0? What?
-5.
Yeah. So x equals -5 would make this 0. So that would be our excluded value. Good. Now in this one, y equals 1 over x minus 1 describe the domain and range. They want us to graph it as well. When we are looking to graph this, first we want to look at what is our excluded value. What can x not equal? On the bottom, what can x not equal? X equals what number that would 0 out? 1. So that would be here. X cannot equal 1. So I'm just going to put a dotted line in there. Because x cannot equal 1. Now, with the rest of this function, like we've talked about in the past, whatever's happening directly to x moves us over a little bit. So our parent function looks like this. That's pretty sloppy, but that's our parent function, right? Now x has a -1 right next to it, so we're moving 1 to the right. So now we'd be moving 1 over, just like that. You see how we moved everything 1 to the right? Okay. Questions? Go ahead, take just a second, find the excluded value, graph the functions. Number 1, number 2, you should be able to already see right now what the excluded value. Why don't we talk about number 1 and 2? What's the excluded value of number 1, Joe? What can x not equal? What would make that bottom 0? Yeah, 0. There's number 1, x equals 0. That's the excluded value. Number 2, Amber, what can x not equal? Yeah, can't equal 4. There you go. Number 1 and 2 done. Go ahead and take a second to graph number 4 and number 5. And those should be in class kit. Now we've graphed a lot like number 4 before, right? That's right here. But we have the negative sign in front, so we need to see how that moves these, or where that puts these two functions then.
Good job, Joe.
Now, for number 5, what is the excluded value? X equals what? Well, if we put 2 in for x, then we would have right. Yeah, -2. So if we go to -2, then we can't have it. That's way off, but we can't have it equal -2, right? So now, here's our graph. Moved over just a couple points, those couple units. Something like this is all I'm looking for number 5. That you put that dotted line in saying, hey, I know that x cannot equal -2, and then you just draw in those 2 graphs. So why don't we keep moving? Here's a new term for us. An asymptote. Now, I know you should have seen, you guys, well, maybe because it's a smaller class, or you guys are waiting on the sure. We talked about asymptotes in my Algebra 2 class, and they all think it's a really fun word. So if you want to laugh, you can laugh at it right now, but we can all understand that it's very close, and it sounds like the beginning of another word that starts with an A. But we'll laugh at it now, and then every time I say it past now, we don't need to laugh, right, Layton? It's not that funny. But all you need to remember is we're not asymptote touchers. So you'll see what that means in just a second. An asymptote is a line that a graph approaches, but it never intersects. So our graph will get closer and closer and closer to the asymptote, but it will never intersect. You're not asymptote touchers. You do not touch the asymptotes. Now, does this sound like something we've already talked about? Lines that we would kind of get close to, but a line that we can't intersect? What does that sound like? Well, Well, yeah, like in this example right here. This is what Joe's getting at. With this example right here, we talked about this will get closer and closer and closer to 0, but it will never intersect it, right? X cannot equal 0. It'll get close, the closest it can get, but it will never intersect. So in this case, we would call x equals 0 and y equals 0. We would call those asymptotes. All right? New vocab word for you. It's the same idea with our excluded value, something like we just write x for this one. We knew x could not equal -2.
Excuse me, may we have Grace Sherwood come to the counseling office, please?
Absolutely.
Thank you.
Bye. We knew that x equaled -2 was our excluded value. Now when we graph it, we put that dotted line in, and on the graph, we call this our asymptote. It's that line that we approach but never cross. How we doing? You guys stay with me? You doing okay? All right. So let's talk about asymptotes a little more. The graph of a rational function in the form, this is a form we've seen before, like what we've talked about today. Y equals 8 over x, or maybe we have a +1 here and a -2 out here. That's the form it's talking about. Has a vertical asymptote, x equals h, so we find our vertical up and down asymptote by looking here. We find the horizontal by looking out here. Like we said, right next to the x, that moves us left and right. Outside of the x, away from the x, moves us up and down. Okay, an example would be what's up with it. Identify the asymptotes of the graph, describe the domain and range. Even though it doesn't directly tell me to graph it, I'm going to. So I think that's the easiest way to see what the asymptotes are. So if we look here, what can x not equal? 2. So x equals 2 is one of our asymptotes. That's something that we will get close to but not ever touch. Also, we have x minus 2. We would think that means we're moving 2 to the left, but nope, psych, we're moving 2 to the right because x cannot equal 2. There's -4 at the end. How does that move us? Yep. And we would draw in another asymptote. At y equals -4. Now this is a positive function, right? So we know it'll look like this. So whenever we graph these, what I would expect to see is that you have your dotted asymptote in within label, right? Or label x equals 2, y equals -4. And then draw the graph. And then it says describe domain and range. So our domain, our x values, it could be all real numbers except for what? 2. Our range, all real numbers, Joe, except for what? What will y never equal? Well, go ahead, look at the graph. What will y never equal? What is our asymptote on the graph? Well, that's our x, right? It'll never equal x. X will never equal 2. -4. Yep. Because right here, our point is 2. It will never be x equals 2. There are your last 2 practice problems. And that's all that we have for today. Well, we have a worksheet, but like that's the new learning tool today. Really quick, let's take a poll of the room. Are we thumbs down, thumbs middle, thumbs up? Where are we at? You be honest. If it's thumbs down, that's okay. Where are we at? Abby, where are we at? between, halfway between. Okay, good. You guys did a nice job. So, knock out those class kick problems. We already did